Welcome to the deep dive. We are so thrilled you could join us today because we have a stack of sources that, frankly, completely broke my brain in the best way possible.
He's definitely a mind-bending sack of papers.
Right. We're tackling some incredibly dense theoretical physics, a healthy dose of quantum biology, and, somewhat surprisingly, a few paleomagnetic archaeological
Yeah,
papers.
the archaeology one really throws people off at first.
It threw me off. But our mission today is to extract the ultimate aha moments from all of this and translate it into a framework we can actually wrap our heads around. We are exploring a wild new paradigm called the Unified Theory of Informational Spin, or TGU.
Along with some really fascinating theories of scalar consciousness and the evolution of sentience itself. It
Exactly.
is a massive scope. But the payoff is immense when you start seeing the underlying patterns. The primary sources we are pulling from include the groundbreaking TGU papers authored by Henry Matachaki,
Which are incredibly mathematically dense.
very dense, plus a highly debated model known as the consciousness spectrum, extensive research on observer-centric reality, and that really fascinating study on hominin fossils dating back 773,000 years.
Right.
The goal here is to take these highly technical concepts and break them down. By the end of this, you should have a clear picture of how the universe might not just be a collection of particles, but a giant, self-organizing informational network.
Okay, let's unpack this because I want you listening to really grasp the scale here. What if gravity, the dark matter supposedly holding our galaxies together, the DNA coiled inside your cells, and your very own human consciousness are all driven by the exact same mechanism?
It sounds like science fiction.
It does. What if it all comes down to a fundamental fabric of what the sources call informational coherence?
That is the core premise of TGU right there.
Yeah.
The theory posits that reality isn't just constructed of dead matter floating in empty space. Instead, information itself is the foundational building block.
Information, not matter.
Right. The way information spins, organizes, and dissipates is what actually creates the physical phenomena we experience. It is a complete rewrite of how we understand cosmic architecture.
I want to start right there with the cosmic architecture. How does TGU differ from the mainstream general relativity we've all accepted? Like, for anyone listening who is new to theoretical physics, we're usually taught that mass dictates gravity.
Right, the bowling ball on a trampoline analogy.
Exactly. Massive objects warp the fabric of space-time, and that geometry tells smaller objects how to move.
General relativity has been our operating system for over a century, and it models the macro universe incredibly well. But TGU challenges the fundamental nature of that model. In TGU, gravitation is not a fundamental force caused by mass curving spacetime.
It's not.
No, gravity is viewed as an emergent force. It is the byproduct of informational coherence gradients. To put it in everyday terms, information naturally wants to organize itself.
Okay.
When you have regions where information is highly organized, structured, and dense, an attractive force emerges to maintain that stability.
So gravity is just the universe's way of keeping its data neatly filed together.
Well, the mechanism is a bit more dynamic than a filing cabinet. Think of it more like a massive, complex network trying to optimize its own connections. The sources use the concept of informational density gradients to map the entire cosmos. They denote this informational density with the letter I.
Got it.
In areas where you have a high informational density, a high I, the universe generates massive cohesive structures. This is the underlying mechanism that TGU claims creates galaxies, as well as those massive cosmic filaments that stretch across billions of light years.
So high I creates galaxies and filaments. But what about the cosmic voids? There are massive pockets of the universe where there's seemingly just nothing.
Those voids represent the opposite end of the spectrum. They are regions characterized by high dissipation and low informational coherence. The emergent force of gravity driving all these cosmic structures is described mathematically in the TGU papers as F equals the gradient of epsilon of R times I.
Okay, you are going to have to translate that math for me. F is obviously the force, but what are those other variables doing?
Sure, let's break down the notation. The gradient represents the change over a distance. Epsilon of R is the critical factor. That is the measure of informational coherence at a specific radial distance from a center.
Okay.
And I, as we mentioned, is the informational density. So the force pulling things together isn't just about how much mass is there. It is dictated by how the coherence of information changes across a given space, multiplied by the raw density of that information.
Wait, if gravity is dictated by informational coherence, what happens to dark matter? The whole reason astrophysicists invented dark matter was because the visible mass of galaxies isn't enough to keep them from flying apart as they spin.
This is where TGU makes its most aggressive claim against mainstream astrophysics. TGU argues that dark matter doesn't exist. The theory removes the need for it entirely.
You're saying we can just throw out the invisible galactic glue that supposedly makes up a quarter of the universe. I imagine the astrophysics community has some strong thoughts on that.
Oh, it is highly controversial. But the math TGU provides is compelling. The theory introduces a specific coherence factor, written as epsilon of r to the negative 1/2 power.
Why the negative 1/2 power? What does that actually represent physically?
It describes how informational coherence scales outward from the center of a massive structure. The beautiful thing about that specific mathematical scaling is that it perfectly mirrors the flat rotation curves we observe in galaxies.
So it solves the math problem dark matter was invented for.
Exactly. If you apply this coherence factor to something like the galaxy NGC 3198 or even massive superstructures like the Hercules Corona Borealis Great Wall, TGU predicts their stability and rotational speeds flawlessly. It accounts for the missing mass purely through the binding energy of informational coherence.
Without needing a single particle of invisible dark matter.
Not one.
That is wild. It cleans up the math by treating the galaxy as a coherent data structure rather than a leaky bucket of matter. But what about the other side of the dark sector, dark energy? We observe the universe expanding, and that expansion is accelerating. Standard physics says dark energy is pushing it apart.
What's fascinating here is how TGU reinterprets the very observations we use to prove dark energy. Astrophysicists rely heavily on type Ia supernovae.
Right, the standard candles.
Exactly. Because these white dwarf stars always explode with a very consistent peak brightness, they're used to measure immense cosmic distances. The faintness of distant standard candles is what led to the discovery of the accelerating universe.
Right, they are cosmic lighthouses. We know how bright the bulb is, so if it looks dim, we know exactly how far away it is.
That is the standard assumption. But TGU argues that the explosion energy of these supernovae isn't universally constant in the way we think. Instead, it is regulated by the informational coherence of the surrounding space.
Oh,
Yeah, the TGU equation for this is E sub Sn equals the gradient of epsilon sub Sn times I, all multiplied by the mass of the supernova.
let me make sure I'm following this. The energy released by an exploding star is dictated by the density of organized information in its immediate environment right before it collapses.
That is the implication. And because informational coherence varies across the cosmos, the brightness of those standard candles might be modulated by the informational density of their local space, not just their distance.
So our measurements could be skewed.
Precisely. Furthermore, TGU demonstrates that the acceleration of the cosmos isn't driven by a mysterious dark energy. The acceleration is merely the macroscopic variation of informational coherence. As the universe's information reorganizes and dissipates on a grand scale, the physical fabric expands.
So no dark matter, no dark energy, just information trying to balance itself. That covers the intergalactic scale, but let's zoom in a bit. Does TGU hold up in our own solar system? Because the ultimate test for Einstein's general relativity was explaining the weird wobble in Mercury's orbit.
Yes, the perihelion precession of Mercury. Newtonian physics couldn't account for a tiny discrepancy in Mercury's orbit, a shift of about 43 arcseconds per century. Einstein's curved spacetime predicted it perfectly, which was a monumental triumph.
Right.
TGU, however, achieves the exact same result using a completely different mechanism. It calculates a perihelion advance of 42.98 arcseconds per century, which is within 0.02 arcseconds of Einstein's prediction.
If it's not curved space-time, how is TGU making that calculation?
Through a process it calls harmonic modulation. TGU calculates the gradients of informational coherence interacting between Venus, Earth, and Mars. Essentially, Mercury isn't rolling along a curved trampoline. It is surfing on the informational interference patterns generated by the other planets in the solar system.
I love that visual. The solar system as an interconnected web of overlapping information, which actually brings up a huge question I had while reading the sources. We have this archaeological study about hominin fossils from 773,000 years ago.
Right, the paleomagnetic data.
Yeah, I spent 20 minutes staring at that paper wondering why on earth paleontology is sitting next to equations about Mercury's orbit.
It seems completely disjointed at first glance, but it serves as a crucial bridge between the macrophysics of planets and the microphysics of biology. Those specific 773,000-year-old fossils correspond to a major geological event called the Matuyama-Brunès transition.
That is the last time the Earth's magnetic poles completely reversed, right?
Yes. The global reversal of Earth's magnetic polarity is a highly precise marker in our geological record. The source titled The Architecture of Ancient Information takes this event and applies the TGU framework to it. The Earth isn't just a rock. In TGU, a planetary system is a central node of informational coherence.
It's actively maintaining itself.
Exactly. It actively maintains its stability, including its magnetic and symbolic polarities, against the increasing entropy or chaos of the broader universe.
Okay, but how do the hominin fossils fit into a magnetic pole reversal?
During a magnetic flip, the Earth's informational node undergoes massive reorganization. The environmental complexity surges. The hominins living through that transition were forced to adapt to a rapidly shifting informational environment. The source suggests that their emerging sentience, the rapid development of their brains, was a biological adaptive response.
To process the new information.
Right, they were literally increasing their own internal informational coherence to survive the chaotic reorganization of the planet's informational node.
Here's where it gets really interesting. If the Earth is a macro node processing information to stay stable, and biological life acts as a micronode doing the exact same thing, how deep does this go? How does TGU explain the actual mechanics of our biology, like human DNA?
This is where TGU stops being purely astrophysical and enters quantum biology. According to the framework, DNA is much more than a static chemical blueprint. It operates as a quantum antenna.
A quantum antenna?
Yes, it actively receives, processes, and stores informational coherence from its environment.
A quantum antenna inside our cells. That sounds like science fiction. The sources dive heavily into DNA methylation, the process where chemical tags turn our genes on or off. How does TGU view that?
TGU models DNA methylation as a physical manifestation of informational compression. By adding those chemical tags, the DNA is optimizing its genetic storage. It is regulating biological entropy.
Fighting off cellular decay.
Right. Maintaining genetic stability by compressing vital information into a more coherent state. It is the exact same fundamental principle that holds a galactic filament together, just operating at the molecular level.
The same mechanism replacing dark matter in space is stabilizing our genes.
Exactly.
If DNA is a quantum antenna organizing information to keep the body from decaying, how do we make the leap from cellular maintenance to actual thought? How does a physical structure generate self-awareness?
To bridge that gap, we have to look at the consciousness spectrum source. This model pushes back against the idea that consciousness is a magical byproduct exclusive to the human brain. Instead, it proposes the consciousness triad. The triad consists of three necessary components: purpose, memory, and adaptive response.
Purpose, memory, and adaptive response. So if a system has those three, it possesses some degree of consciousness.
According to this model, yes. Consciousness is viewed as an emergent property of highly coherent information systems. We can observe elements of this triad across biological systems, like single-celled organisms adapting to threats, and arguably within complex artificial systems, too.
The sources take this a step further with the observer-centric reality research. They suggest consciousness is an actual physical field in the universe.
They do. They model consciousness as a scalar field. The mathematical notation used in the papers is phi sub c of x and t.
Okay, let's break that one down too. What are those variables?
Phi sub c represents the magnitude of the conscious field itself. The x represents its distribution across spatial coordinates, and the t represents its evolution over time. In classical quantum mechanics, there is the famous wave function collapse.
Right, Schrödinger's cat.
Exactly.
Yep.
A quantum particle exists in a blur of multiple possibilities, a superposition, until it is observed, at which point it snaps into a single definite state. This source posits that wave function collapse is triggered specifically when a quantum system becomes entangled with this scalar conscious field.
Wait, so our physical brains are interacting with a background field of consciousness, and that interaction forces reality to make up its mind?
That is the theory. And TGU even proposes a biological anchor for this interaction, the centromeres. These are the central structures of our chromosomes. TGU suggests that these centromeres might function as central nodes of quantum coherence within the body, linking our physical biology directly to this universal scalar field of consciousness.
Just to summarize the sheer scale of this for you listening, The exact same mathematical framework of informational coherence that eliminates the need for dark matter to hold intergalactic superclusters together is the exact same framework that stabilizes the DNA methylation inside your cells and provides the mechanism for your consciousness to collapse quantum possibilities into reality. It is one unified rulebook.
It is breathtakingly elegant. It connects cosmology, paleontology, and quantum biology. But elegance doesn't automatically mean it's correct. A theory this disruptive faces astronomical experimental hurdles.
That is the million-dollar question, isn't it? We can't just assert that the universe is made of information and call it a day. The burden of proof here is massive. How do we actually validate these claims, starting with the biology?
For quantum biology, the validation steps are rigorous. We need highly precise real-time measurements of how informational coherence physically impacts epigenetic processes like methylation.
Which is incredibly hard to measure.
Extremely hard. Scientists would need to design lab experiments capable of measuring the interaction of informational spin directly with living systems. We have to isolate and observe the exact moment a biological structure acts as a quantum antenna, independent of classical chemical reactions.
And what about proving the astrophysics side? Taking on general relativity and dark matter is going to require some serious physical evidence.
If we connect this to the bigger picture, the cosmic proofs require advanced interferometers, like the LIGO and Virgo gravitational wave detectors.
The same facilities that detect black hole collisions, what are they looking for to prove TGU?
They would be looking for very specific polarization anomalies in gravitational waves, specifically the H plus and H cross modes.
I'm going to need you to define H plus and H cross for us.
When a gravitational wave passes through space, it stretches and squeezes the fabric of reality. The H plus polarization squeezes in a cross shape, up and down, then left and right. The H cross polarization does the same thing, but rotated 45 degrees like an X.
Okay, I can picture that.
General relativity predicts a very specific, clean pattern for these polarizations. TGU predicts that if massive informational lenses exist in space, they will modulate these H plus and H cross modes, leaving a unique, observable signature that Einstein's math cannot account for.
And what about proving TGU here on Earth? Can we test informational coherence in a physics lab?
It's theoretically possible. In a controlled laboratory setting, scientists would need to utilize high-coherence laser cavities, quantum oscillators, and ion traps.
To do what exactly?
The objective would be to artificially induce informational collapse. If they can prove that manipulating information density alone can cause a measurable physical force or state change, TGU gains massive credibility.
That sounds like it will take decades of research and a lot of funding. But let's bring it back to the immediate practical application. Why should you, the listener, care about this from a technological standpoint? If TGU is proven right, what changes?
If TGU's underlying mechanics are correct, it paves the way for unimaginable breakthroughs, most notably in quantum computing.
Because the biggest hurdle in quantum computing right now is decoherence, right? The qubits, the quantum bits holding the data, are incredibly fragile and lose their state at the slightest environmental noise.
Decoherence is the absolute bottleneck of the industry. Right now, we fight the universe to keep qubits stable, usually by freezing them to near absolute zero. But TGU proposes that by deliberately manipulating informational coherence gradients, we could engineer natively stable qubits.
So we stop fighting nature.
Right. We wouldn't be fighting the universe's natural state. We would be aligning with it, just like Mercury's surfing the informational waves of the solar system.
We would be building computers that process data the exact same way the universe processes gravity.
Precisely. This could lead to the creation of quantum neural networks that are infinitely more efficient than current systems. We wouldn't just be building faster calculators, we would be fundamentally mimicking the architecture of the cosmos. It would revolutionize artificial intelligence, complex modeling, and how we interact with the fabric of data itself.
So, what does this all mean? We have covered a staggering amount of ground today. We started by looking at cosmic voids and galactic walls, realizing they might be shaped not by dark matter, but by the physical weight of information. We looked at how Earth maintains its stability against cosmic entropy, tracking a magnetic flip from 773,000 years ago, and how hominins adapted to it.
It's quite the journey.
And we traced that exact same principle down to the scalar fields of human consciousness and the DNA coiled inside your cells.
It represents a total paradigm shift. It moves us away from viewing the universe as a cold machine made of dead parts bumping into each other. Instead, it presents the universe that is alive, interconnected, and driven by coherent information.
And the most important takeaway for you listening right now is this. You are not just a physical body floating randomly in an empty void. If these theories hold weight, you are a highly coherent node of information. By existing, observing, and processing your reality, you are actively participating in the stabilization and evolution of the universe.
And if you want a truly mind-expanding concept to mull over tonight, consider how these sources apply Gödel's incompleteness theorem to that very idea.
Wait, Gödel's incompleteness theorem, the mathematical theorem, how does that apply to cosmology?
Gödel mathematically proved that any sufficiently complex system cannot prove its own consistency from within. It inevitably contains undecidable statements. It requires an external perspective, an oracle, to validate it.
Okay.
The sources propose that physical reality, the universe itself, is a complex system that is inherently incomplete on its own. It requires an external selector to collapse its undecidable quantum states into a definitive reality.
Are you saying consciousness is the oracle?
That is the implication. Consciousness acts as the Gödel oracle for the cosmos, which raises a staggering question. Does the universe actually require your consciousness and the consciousness of every sentient being just to remain mathematically and physically stable? Without you to observe it and organize its information, would the universe simply unravel back into chaotic superposition?
Wow. I have chills. That is the ultimate thought to leave you with today. Are you the anchor keeping reality intact? We want to thank you so much for joining us on this deep dive. The universe is endlessly fascinating, and there's always more to discover. Stay curious, keep exploring, and we will catch you next time.